Yes, guys. Now, before going to start the problems on force and dipole, first of all, the linking concept related to electric dipole. So, electric dipole is a system of two charges opposite in nature separated by the finite distance 2L. L is small here. So, dipole momentum is a physical quantity which explain about the dipole. P is equal to 2L into Q. You can go with 2L bar into Q, and it is a vector physical quantity. The net charge of the dipole is 0. That means net charge means Q net is equal to plus Q minus Q, that equal to 0. But field is not equal to 0 by the dipole. So two charges separated by finite distance 2L with a very small displacement. Distance between plus Q and minus Q is very small here. You have to consider like. So now our questions are means here the questions on this dipole will get like this. The question number 1 is field. So in the field, three steps. One is on axial line. Second one is on equatorial line. The third one is any point. Similarly, second one potential. Potential of a dipole at all these three places. So third one force. The fourth one work done and potential energy. Work done and potential energy. Potential energy. So these are the main topics and question related to the force is very important. So here force also will find out. Force on dipole means, but that means two dipoles. Force on a dipole and point. Force on dipole and point charge Q. Force between dipole and charge Q. And force between the charged body. This is the point charge and another one is charged body. So this topic you have to study. The questions on this topic like this only. Once again, field three places, potential on 3 points at the 3 points, force in three models, and work done potential energy by dipole. So for coming into force in uniform field, in uniform electric field, and a non-uniform electric field. After knowing the force, we'll go with the torque also. Torque of a dipole. So these are the questions related topics in a dipole. So let's come to field intensity on axial line of a dipole. So this is electric dipole. The same concept and the same topics you will study in magnetic dipole also. There instead of plus north pole, instead of minus south pole will come. That is only the difference. And remember, dipole is a system, not the particles of charge. These two behave like a one dipole, one atom or molecule. Atom or molecule. That means based on the dipole momentum, if dipole momentum is 0, dipole momentum is 0. That means center of positive charge and center of negative charge lies in the same place. Lies in the same place. Such molecule is called. Such molecules is called. Means its dipole momentum is zero. Their dipole momentum is zero. Such molecules are called the non-polar molecules. The non-polar molecules. So example CO2 and CH4. Similarly, dipole momentum whose dipole momentum is not equal to zero. Here dipole momentum is zero for these non-polar molecules because there is no distance between positive and negative molecule. Right. Means positive center of positive charge and center of negative charge is same place. Means whose dipole momentum is zero. Whose dipole momentum is zero. That means center of positive charge and the center of negative charge lies in the same place. So those molecules are called non-polar. Example is given. This is the physical existence of dipole. Similarly, H2O, polar molecule. Polar molecule. Means dipole momentum of molecule is not zero. Something present. That means there will be a distance between nucleus and the electrons. H2O, H2. H2 is on dipole. So this is physical significance of dipole. Means here this positive dipole means the system of two charges, positive and negative, and their amount of means magnitude of charge is equal. The nature is negative. Proton and electron combinedly called as one dipole. So atoms are example for dipoles. And molecules, non-polar molecules, polar molecules. Non-polar molecules means dipole momentum is zero because their centers, positive center and negative charge center lies on the same place. So this is about dipole momentum. And the direction of dipole momentum, we know it is always from negative q to positive q. Opposite the field between these two charges, dipole momentum. So field between the two charges towards positive to negative. That is already in electric field concept. But here dipole momentum is opposite to this field direction between the two charges. The system of these two charges is called dipole. Now consider the unit positive charge at the point P. At the point P, unit positive charge here. And the field at this point. So due to the dipole, not by these two charges. That's why the distance I will consider from middle point of the dipole. So the distance D is the midpoint of dipole. So whereas the distance of dipole is 2L, then this distance negative q to this point is L, and this point to negative q is equal to L. Now here unit test charge is always 1 coulomb, positive 1 coulomb. Therefore, the field on this point at this point is act like this: E positive and E negative. This is field by negative charge, and this is field by positive charge on this point. So here it is very clear. E positive means field formula K into Q by D plus L whole square. So here also K into Q by D minus L square by negative. So here K is called 1 by 4 pi epsilon. We know very well. Always will substitute. In some of the books they will go with A R K. So which is equal to 1 by 4 pi epsilon. And in problem solvation, we'll follow this is equal to 9 into 10 to the power of 9 value. This value is this value. The units are force means Newton by meter square. Oh, sorry, Newton by Newton meter square by Coulomb square. Newton meter square means Coulomb square by Newton meter square. So 1 by 4 pi epsilon the electric constant. So means epsilon naught value. This is, but this value will substitute without unit in SI unit 9 into 10 to the power of 9. This is SI unit. So now here the field resultant field at the point P by dipole is equal to E plus minus of E minus. So if you substitute these values, KQ into D minus L whole square minus of D plus L whole square by D square minus L square whole square. Because LCM A plus B into A minus B whole square equal to A square minus B square whole square. So which is equal to KQ into here minus 2dl and here also minus 1 2dl, D square L square get cancelled, it will become minus of 4dl by D square minus L square whole square. So where L is very less than compared to D value, then L square is neglected. So then I can write that equal to here see the minus Q into 2L, I can go with P, right? Therefore 2 into 2QL is P bar dipole momentum by into D by D for 4. That implies minus 2K P bar by DQ. So this is the field D2 dipole on a axial point at D distance. The dipole distance from center to that point where you have to find out the field. And here is minus indicates. So here minus indicates it will be in the direction of negative x-axis or along the P. So the direction of E, here I have explained direction of P is along P means both field and dipole momentum lies along the same direction. When the field on axial line. So coming into field D2 equatorial line. So if you integrate this one, you will get potential. So we know potential is equal to dV is equal to minus integral E dot dr. So if you integrate, you will get this is Kp by R d square will get 2 cancels Kp by d square. This is the potential. Anyhow, I will explain about the potential topic, how to calculate this value. We'll see that. So now coming into field on equatorial line of a dipole. So let's consider a equatorial line. So now this is positive Q, this is negative Q. This forms the system forms a dipole. As we know, this line is axial line. So now let's consider a equatorial line. This is the point. Equatorial line is bisecting line. In the distance t from the axis of dipole, the distance d, there is one point having plus 1 coulomb of charge. Yes. So if you see here, I want to find out the field of dipole. So this is unit test charge. The field is like this. And here this is a D2 negative charge. The field is like this. And the dipole momentum is in this direction. This is the direction of dipole momentum P bar because negative charge to positive charge. If you see here, this is E positive as well as E negative are same in magnitude. The E positive and E negative are in same in magnitude because the distance is same, charge is same. So this will be root over d square plus L square. So now if you take this total as theta, now the angle between two fields is become 180 minus 2 theta. Therefore 180 minus 2 theta is angle between two fields. Two fields at a point P or field on unit test charge. Now so field formula, so the resultant field is equal to the root over E square plus E square plus 2E square into cos of 180 minus 2 theta. So 180 minus 2 theta is the second coordinate, therefore cos of 180 minus 2 theta is equal to minus cos 2 theta. So therefore E is equal to root over 2E square minus 2E square cos 2 theta. 2E square take common. The 2E square in vectors, it is these formulas and all we have already solved. For newly who are listening this concept, for their purpose I am giving everything neatly. So we know 1 minus cos 2 theta is equal to 2 sin square 2 sin square theta from the cos 2 theta formula. So therefore this is the answer, 2e sin theta from the square root. So E resultant is equal to at that point 2e sin theta. So which I can write, I know the value of E. So the E value is equal to E positive or E negative is equal to K into Q by L square plus D square. Small L square plus D square. So and the sin theta value from the diagram. From here diagram, see if you see diagram sin theta. So this total is theta I have taken. And sin theta by 2. This is 2 theta I have taken for this purpose only. Then sin 2 theta is equal to, this is total 2 theta. Now this alone theta will come. Therefore sin theta is equal to L by root over L square plus D square. So now if we substitute here, we will get answer 2 sin theta is equal to 2 into KQ into L by the L square plus D square whole power 3 by 2. So we know already L is very less than D, then L square will be neglected. Right. So then answer is equal to, that is equal to K into 2QL I can take as P bar, dipole momentum of the system of two charges, and this is L square neglected means dQ. So therefore the field due to dipole on equatorial line is equal to K into P bar by dQ. So in magnet we will go with the magnetic momentum, same formulas, capital M will write this. mu naught by 4 pi. In the place of K they will write A there, mu naught by 4 pi, symbol different. M by dQ, tan B position, tan A position. And if you see very clearly this E equivalent here, so it will be act along like this, right? This is the resultant field. Now the direction of field, so tan phi you can find out here, that we will discuss later. The direction of field due to the dipole on equatorial line is opposite to the dipole momentum, is very important in calculation of forces, dipole interaction and potential energy, calculation of potential energy between the dipoles. So this is very important. So if you see clearly, an axial line, dipole momentum and the resultant field is same direction. If you see here, the resultant field and dipole are in opposite direction. So this now the electric field would be at any point, field due to dipole at any point. So let's consider here again dipole. Dipole is plus Q and dipole is minus Q. Another charge in the dipole is minus. These two are separated by the finite distance, that is 2L. So here, for understanding, for completion of diagram only, we are taking this much distance, but generally these are small only. This is equatorial line, we know. So this line is called axial line. So now somewhere there is a point P here. Here is a point. Now this point, the line joining this point is making angle theta with dipole. So this is take as plus, then it will be dipole. Dipole momentum P bar. With P bar, theta is the angle between the line joining P, joining a point, and dipole momentum P bar. So if you see this P bar resolve into two components, P bar means dipole momentum resolve into two components. One is along this line and one is perpendicular to that line. One is along this line, that which is equal to P cos theta, and perpendicular to that line P sin theta. That means this point is axial line on axial line for dipole momentum P cos theta. It is an equatorial line. It is an equatorial line for P sin theta. So dipole momentum is P sin theta. So now that point P lies in equatorial point. If P cos theta is the dipole momentum, so then P lies along the axis of P cos theta dipole momentum. So then we know these two are dipole momentum by axis point to 2P. Here P is equal to cos theta dipole momentum and the sin theta if you substitute. Here I have given clearly. So now E at any point you will get this. So here you can substitute theta is equal to 0. That means P lies on axial line. So T is equal to 90 degrees. Theta equal to 90 degrees. Then P lies on equatorial line. If any spelling mistakes, don't consider. Our understanding concept are not check once. If people have any doubt, you can comment, leave the doubt in comment. I try to give you explanation, right? So point P lies an axial line for the dipole momentum P cos theta. Then axial momentum, dipole momentum, we know already, that I have written here. Here dipole is equal to P cos theta. And here dipole momentum is equal to P sin theta. This theta and here substitute means you will get the same answers. So this is about the dipole momentum of a dipole, means dipole field, electric field of a dipole on three different points. One is axial, equatorial, and any point. So now there is another question. I will come to that. Now potential due to dipole on a equatorial line and axial line. First we will find out the potential. These are the problems. Next I will go to uniform electric field. Right. So potential due to dipole. So let's consider dipole once again. So I hope you are following the concept. So let's have a dipole. So this is positive Q and this is negative Q, and these two are joining by the finite line, which we will call as A or 2L. So let us have a one point. The P is the point from the center of the dipole, which makes angle theta. So now the negative Q is in the distance R1 and positive Q is in the distance R. So this is R. So here is the point P. So for potential, no need to give any direction. So now potential at point P is equal to KQ into 1 by R2 minus 1 by R1, because we know potential for positive charge is positive, potential for negative charge is negative. So that is equal to KQ into the R1 minus R2 by R1 R2. So this is potential formula. So here R2 and R1 in terms of L and momentum, dipole momentum, I need to change. So for that, what I will follow means, so if you draw a normal from the P line to R2 to make the distance are equal like this, one perpendicular line from R to P2. Now this length will become L cast. This is the L hypotenuse and here also one L. So now this will be L cast. Similarly, draw a perpendicular from R to the R1 line. So now this distance also will become L cos theta. That means, see from the diagram, R2 is equal to R plus L cos theta, L into cos theta. Similarly, R1 is equal to R minus L cos theta. So now R1 minus R2, R1 minus R2. So that equal to minus 2L cos theta. So now R1 R2, R1 into R2. So which is equal to R square minus L square cos theta according to A plus B into A minus B. And we know that L is very less than here R. So now L square is neglected. So now R1 R2 become R1 R2 is equal to R square. So now substitute, therefore V is equal to KQ into minus 2L cos theta by R square. So here Q into 2L I can take as dipole momentum. So that equal to, here minus is potential due to the conservative field. So now K into P cos theta. K into P cos theta by R square. So now here case 1. So here you will go for case 1. So if theta is equal to 0, now P lies on axial line. P lies on axial line. Axial line of dipole. So then the potential is equal to Kp by R square. The potential is equal to Kp by R square for axial line. Means potential on the axial line of dipole is Kp by R square. So here we studied already. So on axial line Kp by R square means d square here. So I have given C here. So now coming into theta is equal to 90. So theta is equal to 90. That means equatorial line. P comes to equatorial line. Theta equal 90, P comes to equatorial line. So then V becomes to 0. So on equatorial line, potential is 0. On axial line, potential is equal to Kp by R square. And why it is 0? Means on equatorial line, the distance from plus Q and minus Q are same. Then you are integrating for same values, you will get 0. R to R. Or some root over L square plus D square to root over L square plus D square on equatorial line. So now integrating the E dot dr potential by taking the E on equatorial line. So you will get 0. Or we can prove from this the V is equal to Kp by Kp cos theta by R square. So from this formula also we can. So I understand the potential of a dipole. So this is at any point. This is an axial line. So this is an equatorial line. Potential. So electric field is over for 3 points. Potential is also over. Now coming into see here one question. Very important this is. So now direction of the field at a point phi from the dipole. If theta is the angle between line joining the dipole momentum, and point P, then phi is the angle between resultant field and field on axial line. Then tan phi is equal to how much? On this also two more questions are there. We'll discuss. So let's consider. So x and y axis. So this is the along this dipole momentum is there. From this there is a one point P, which is making angle theta with the dipole momentum. With the dipole momentum. This is small dipole, but I am drawing the bigger. Don't consider that is big dipole. Very small dipoles are these. So at this point, so as we discussed earlier, P cos theta, P sin theta. So this is the E axial. And now dipole opposite to dipole momentum. So there is a E. So there is a E equatorial. So opposite to this one. Opposite to field. So now the resultant field of these two is E, is making angle phi with E axial and theta with horizontal x axis or dipole momentum. So then if you see here, tan phi is equal to E2 by E1. E2 by E1. So now E2 is equal to, that equal to K into equatorial line E2 P cos theta by dq. So this is, let's consider R is the point of P from dipole, then RQ. By E1 is equal to axial line K into 2P sin theta by RQ. Okay, the resultant field. So now tan phi is equal to, therefore tan phi is equal to, so tan phi is E2, E equatorial line by E axial line. E axial means 2P cos theta here, sorry. Axial means 2P cos theta. Equatorial means KP sin theta. This is sin theta is equatorial here. P sin theta and P cos theta. So that equal to here cos theta. R cube get cancelled. KP and KP get cancelled. So tan phi is equal to finally 1 by 2 tan theta. So this is the direction of electric field of a dipole at point P direction. The magnitude means root over 3 cos square theta plus 1 by Kp into Kp RQ. Kp by RQ. So here I have given already at any point field. Root over 3 cos square theta plus 1 into Kp by RQ. So now if you take some other examples. So now see, an electric dipole have a dipole momentum P placed at a origin of O. So here, this is the problem. O 0, 0, 0. So dipole momentum and momentum is along x-axis. And at point P and distance R from the dipole, the field is acting along the y direction. This is Ey. That means J cap. Now is asking to find angular position, the magnitude of electric field, and how much angle with x-axis. So the third question is easy. See. So here is very clearly is given. The field is along y-axis. So this is x-axis. So here this is the field of axial line. Field of axial line. The resultant field. So there is a equatorial field also like this, but this is no need here in this problem. Now if we third problem C means the electric field with x-axis how much angle, the resultant E makes an angle dash with x-axis, how much angle is asked me to find out. That is equal, I can say very easily from the diagram, theta plus phi. That is the angle. I want to find out the theta is how much. For that, see, we know very clearly tan phi is equal to 1 by 2 tan theta. And in the diagram according to given, this is x-axis, y-axis means theta plus phi is equal to 90. Because x-axis and EY, y along y-axis, for total angle is 90. Then tan square theta is equal to 2, tan theta is equal to root 2. So theta value is equal to tan inverse root 2, I can write. Tan inverse of root 2 value. Now he's asking to find out theta value is over tan inverse root 2. Now the magnitude of electric field at point P, magnitude of electric field I want to find out. So to find magnitude of electric field at any point due to the dipole, so I know P is equal to, E is equal to, electric field E is equal to Kp by R cube into root over 3 cos square theta plus 1. So to find out the cos square theta, I have a one angle is given tan theta. Tan theta is equal to root 2, that is root 2 by 1. So now here it is root 3. So that implies Kp by R cube into, so this is root 2 will come, that equal to P by 2 root 2 into pi epsilon naught R cube. So direction and theta angle and total angle with x-axis resultant field calculated. This is the right answer and everything is calculated. Now see another problem. So here the charge of Q is given. Plus Q minus Q, 2Q are located in equilateral triangle. Consider equilateral triangle. The three charges are given. In one place minus 2Q, the other place Q and Q. So because of net charge 0, the Q net is equal to 0, it acts like a dipole. So therefore dipole momentum from negative Q, this is the dipole momentum of 1, P1, and this is the dipole momentum of P2, and angle between them is 60 degrees. Equilateral triangle na 60 degrees. Therefore the resultant dipole momentum is equal to, solid in vector we studied, equal vectors with 60 degrees or any other angle means, here with 60 degrees will come root 3 into P. Okay, which is equal to root 3 into, the P means here Q, 2QL, right? P is equal to Q into 2L, the side is equal to A if I consider root 3 into QA. So this is the dipole momentum of three particle system when they are arranged in equilateral triangle. So now coming into same model here. So this is the distance A. Q net is equal to 0 for the dipole. So in the system Q net is equal to 0. So it will act like a dipole. So now dipole momentum. So it is the arrow marks like this and this one is like this. Due to this two charge, second charge and first charge. Therefore the resultant also like this one. Means Q net is equal to 0. The resultant dipole momentum, and here dipole momentum is 90 degrees, then it will be root 2P. So the dipole momentum is same because distance are given same. So P1, dipole momentum of P1 is equal to P2. A minute. There is the pen gun. So now P1 is equal to P2 and angle between them is 90 degrees. So the resultant dipole momentum is equal to the root 2 into P, which is equal to root 2 into dipole momentum QA. Q into 2L. Here 2L is given as A. So I hope you understand these three problems on dipole. So combination of. So today's topic is force on dipole. So this topic we'll discuss. Actually, force on dipole I have to deal after calculating the field and potential energy. because force is equal to Q into E of the dipole, or F is equal to minus du by dr. Or one more method is there to calculate the force. F is equal to E into dE by dx or dl. So these are the three formulas you have to use in calculating force on dipole. Force on dipole. So Q into E of the dipole is in the case of, so like this, here one dipole is there, is the dipole momentum. Here one Q is there, or here one Q is there. So force on dipole by the charge, or the dipole is there like this. So here in the distance Q there is a one dipole, one charged particle is there. The force on dipole by the charge. So that will be used for one method. This is the case one. Now energy is given. So asking to find out the force, potential energy of the dipole is given. Asking to find out. Then du by dr. That means energy formula. So work done. So du is equal to work done. So which is equal to P sin theta d theta. So that can be written as P into 1 minus cos theta from 0 to theta angle. If theta 1 to theta 2 means cos theta 1 minus cos theta 2. So this is equal to P cos theta final minus cos theta initial. Means final orientation from initial orientation. So initially dipole is oriented in one angle. So to other angle how much work is done? This is the work done. So when the work done of a dipole is given, so P into cos theta. So you can find out the force, that equal to force is equal to minus du by dr. So that you can. So like these two formulas, du by dr and P into dE by dx. So use it to calculate. So when dipoles are involved, that means two dipoles are like this. So these two dipoles, center of dipoles are separated by the distance d. So this is the dipole momentum P1, this is the dipole momentum P2. So here force, so is equal to P2 into delta E by delta R of P1. By E by delta R of P1. Yes, E is by first dipole. This is the force on 2 by first dipole. Similarly, the force on first dipole by the 2 is equal to force on first. That means first one in the field of P2. That is equal to P1 into delta E2 by delta R. So in this case, E1 is axial field of a dipole. Axial field of dipole. That means K into first dipole now P1 by dq, the distance between dipoles. Similarly, here E2 is equal to axial, that equal to 2K P2. The field D2, dipole 2 on dipole 1. So dq. That means the dipole 1 is in the field of P2. Dipole 2 is in the field of E1. Dipole 1 field, axial field. So this is one. So if you do this method, you will get, that means dE by dr. dE by dr. Either that is E1 or E2 afterwards. So I know U is equal to Q 2P1 by D cube or 2K P2 by D cube, whatever you take. So here D cube means R. So dE by D. So that is why dr only you have. So that equal to d by dr of E value. 2K into P1 by R cube. So derivation of minus 3 I have to do. That equal to minus 6K P1 by R power 4. So this is dE by dr. Similarly, minus 6k P2 by r power 4. So this is dE by dr. So now here you substitute in these equations these two values. Now I will get the force on 2 by 1 is equal to force on 1 by 2. Both are same. That is equal to 6k P1 P2 by r power 4. That equal to 3 by 2 pi epsilon naught into P1 P2 by r power 4. So this is the force on dipole. Dipole is interaction axially. Dipole interaction axially. That means one dipole and another dipole parallel or anti-parallel. So this is the force. So now I hope you understand when P into dE by dr we have to use, and F equal to Q into E dipole. When you will get F equal to du by dr formula. The maximum of the students will confuse which formula when you have to use. This is the situation 1. This is the situation 1 here. So your dipole is there, either like this oriented or like this oriented. Okay, no? So Q is there. Then the Q has field, or dipole has field. This is the equatorial line. So then force on dipole is equal to E into Q. Or Q has field at this point on the dipole. Then field here, see, F equal to Q into E of the dipole, not E of the Q. Field into E naught. Field due to dipole on Q. That means this Q is on field of dipole. Therefore, force on dipole by the charge Q and force on charge Q by the dipole both are equal. Force on charge by dipole, charge on dipole, and the force on dipole by the charge both are equal. So that's why you'll find out. It is easy to find out the field of dipole because it is an equatorial line. That equal to here. Force is equal to, I will get the Q into E of equatorial. That equal to K P by. So this is D means dQ. So this is the force part. So here also it is on the axial line in the distance d the charge from the dipole momentum. There is a d distance from the dipole momentum. Then also force is equal to here, in this case force on charge or force on dipole is equal to Q into 2kp by dq. So when you know the field of axial line, field of dipole on axial line point, field of dipole on equatorial point. So already in the previous means 10 minutes before I have given that fields, right? The fields we discussed. So now this is. Now coming into another situation in the same model, that is, so dipoles are like this. Consider a situation like this. This is the dipole, one dipole P1, the other dipole of dipole momentum P2. So separated by the distance d. So here it is very clear to find out the force we have to use. The force on 2 by 1 is equal to force on 1 by 2 according to Newton's third law. And direction of dipoles are given. And an equatorial line. Coming on to equatorial line. This P2 is on equatorial line of P1. P2 is equatorial line of P1. And P1 is equatorial line of field of P2. Field dipole. That is equal to, I can write. So P1 into means force on 1. This is the force on 1 by 2. P1 into dE2. That equal to d by dd dr into P2 means E2. ED to the P2 dipole, that equal to on equatorial line Kp2 by r cube. So here this you take as r because dE by dr we are doing now, so it is easy. It means it will not get confused. That's why. So that equal to again r power minus 3. I am integrating, right? So P1 into r power minus 3, that equal to, so minus 3 P1 P2 by r power 4 into K. So that equal to 3 by 4 pi epsilon naught into P1 P2 by r power 4. So this is the force of dipole momentum. So from this orientation, from this formula, we can say the same dipole momentum, dipoles P1 and P2 arranged perpendicularly and here arranged axially. So then force how much I got? 6k P1 P2 by R power 4. But here 3k P1 P2 by k into R power 4. That means the force on dipole is maximum when they are arranging axially. The force on dipole by another dipole is maximum when they are arranged axially. When they are that means their momentum axis axially. So where momentums P1 is equal to P2 and D is equal to same in both the cases. Okay, if two momentums axially arranged, two dipoles axially arranged and perpendicular arranged, then the force on dipole which is parallel to the other dipole feels more or experiences more force. So this is about dipole interaction. So I hope you got this. Suppose another model. See now the force on a dipole when placed in uniform electric field. Now see, so uniform electric field. So let's consider uniform electric field. So no need to explain about the uniform electric field. Means field is same everywhere. So there is a one small dipole is there. So plus q and minus q. So here distance between the dipole is equal to 2L, or you can go with A or something. So as you know, the force on this one is equal to, this is force F minus, and along the field direction and positive, this is F plus. So the force net is equal to 0. So when E is parallel or anti-parallel to P. So E bar and P bar are parallel or anti-parallel, then force is equal to 0. So then in this case, the tau is also 0. Tau is also 0. When the dipole is placed perpendicularly like this. This is plus q and this is minus q. The momentum is perpendicularly like this. So then it experiences the force. These are the forces. So now here F net is equal to 0. This is the case B. This is the case here. In F net is equal to 0 in B case. In A case F net equal to 0. In B case also F net equal to 0 because it is uniform field. But in this case tau is not equal to 0. So tau something is exists. Therefore tau is equal to, we know, force into QE into perpendicular distance. That is equal to the perpendicular distance 2L. So that is equal to PE I can write. So actually we know that tau is equal to P bar cross E bar, that equal to PE sin theta n cap. PE sin theta n cap. So where theta is equal to 90. That means P bar is perpendicular to E bar. So then tau is equal to magnitude. Other cases tau is equal to, means 0 and parallel and anti-parallel, tau is equal to 0 and F net is also 0 in uniform electric field. And tau is equal to PE sin theta n cap in all other cases. Other than 0, 180 and 90, the PE sin theta. 90 means maximum PE torque. And in uniform electric field, when dipole is there, the same thing will be magnetic also. In uniform magnetic field, F net equal to 0, tau is equal to 0, F net equal to 0, tau is PE. So F net equal to 0, tau may be PE. That means when placed arrange in 90 degrees. F net is equal to 0, the tau may be 0. That is case when Q is, means dipole is placed along field direction or anti-parallel to field direction. So similarly non-uniform electric field, the force on dipole in non-uniform electric field. So in this case, how we will find out? Means let's consider non-uniform electric field. That means field is not same. The field is not same everywhere. So let it be like this. So these are the field lines. So let's consider a dipole in this field. So plus q and minus q. So it is in opposite. The momentum, the dipole momentum is opposite to anti-parallel to case 1. The dipole momentum is anti-parallel to field. And if you see here, the field is strong here and field is weak this side. So this side the field is stronger. That means the force on plus q is, let's consider this is F plus, and force is opposite to field direction. This is a force that equal to F minus. Therefore here F net is equal to, so strong force is q side, that is equal to, means positive q side, q into E positive minus E negative. F net is equal to q into E positive minus E negative. That means, so when the momentum, dipole momentum is anti-parallel to E, the force is towards weak field. Towards weak field. Means dipole is pulled or thrown into weak field direction. The F net is equal to this one. Now this I will change like this. For Q into 2L into E plus minus E minus. So E plus is strong field, E minus is weak field. By 2L. I can write like this. So therefore F is equal to, F net is equal to Q into 2L I can write as P into delta E by delta L. So this delta E by delta L is called, so here the delta E by delta L is called the gradient of field. Gradient of field. So dE by dr I used it in finding the force side when two dipoles are interacting, right? Right. So now dipoles and all everything now we will study. Now coming into dipole in uniform electric field. Let's consider uniform electric field. Uniform means, you know, the point charge. We use the non-uniform field. Means field varies with the distance. But if we consider one surface around the point charge, in that surface it is uniform. So now here there is a dipole. This is positive q and negative q. We can arrange like this, or we can take like this also, negative q and positive q. If you see very clearly, the force on positive q by this electric field, constant electric field. So the force on positive charge is same. This is A and B. So this is Fa, and now this is Fb. These two forces are same and opposite direction according to Newton's third law. That's why they will not come closer. So this force is attractive, but they are not coming closer. And now here the force is like this, Fa, and here the force is like this. So the net force is equal to here. The net force is Fa minus Fb. So which is equal to Q into, so E into plus Q minus Q minus, so which is equal to 0. So your net force is equal to 0. F net is equal to 0. And here in this case there is no torque also. Tau is also equal to 0. I will explain why tau is equal to 0 in this case, right? So now coming into another orientation, the dipole, and the net force is 0. So now dipole is the torque subheading I have not given separately, is given the work done. So now torque subheading is not given. So here I will write torque also. So let's consider uniform electric field. So the dipole is arranged like this, perpendicular or with some angle. This is the dipole momentum. So the force is here is along the E direction. This is F positive will come, and the opposite direction here force is like this direction, F negative. So here also F net is equal to 0. But tau is not equal to 0. So two cases here, F net is equal to 0 in uniform electric field. Tau is equal to 0 and tau is not equal to 0. Tau is equal to 0 and tau is equal not equal to 0. So here I want to find out the tau equation. So now see, tau means we know the force into perpendicular distance. So it is the theta angle between dipole momentum and the electric field. Then this is 2L sin theta. So force into perpendicular distance or force into perpendicular distance. So that is therefore tau is equal to here. Tau is equal to PE sin theta n cap. Means that is here I can write the tau is equal to force into perpendicular distance, that is equal to QE into sin theta into 2L. So Q into 2L I can take as PE sin theta and it is n cap. So here n is equal to minus k cap will come. So if you take this is as x axis, this is as y axis. Okay, 2L sin theta is minus j cap and F is equal to positive x I cap, positive I cap field or force, and along the negative j cap, this one is there. So now j cap cross minus j cap cross I cap, that is equal to k cap, right? R bar cross F bar, right? So here R bar is equal to, so from this point to j cap cross I cap, so negative directions. So this I can write P bar cross E bar, tau equal to P bar cross E bar, that is PE sin theta. The magnitude of tau, the tau is a vector we know, that's why n cap. Tau is equal to magnitude of tau is equal to PE sin theta. So where theta is equal to 0 or 180 degrees, 0 or 180 degrees, then tau automatically 0. So you know sin 0 or sin pi is 0. So whereas theta is equal to 90, that means the dipole momentum perpendicular to electric field direction. Dipole momentum is perpendicular to electric field direction. Then the tau is equal to maximum, which is called PE, which is equal to PE. So in this case, the dipole momentum is parallel to E or anti-parallel to E, whatever, whenever tau is equal to 0. P bar is parallel to E or anti-parallel to E in uniform electric field, the tau is equal to 0. The tau is maximum in the uniform field when dipole is perpendicular to the field. Other than any angle, then PE sin theta magnitude of tau. So now coming into work done. So work done on dipole. So the work done is equal to, work done means force into dr, force into dr1. So which is equal to tau into d theta I will take. Because see, in a field, electric field, I will consider as a uniform electric field. It is easy to understand. In uniform electric field E, the dipole is initially in equilibrium condition, plus minus. So it will be like this, dipole momentum P bar in equilibrium condition. To change the dipole momentum, okay now, to change the dipole momentum in this direction, some angle with the field, dipole momentum, some angle with the field. I want to turn this dipole, so into this angle. Means initially, the theta initial is equal to 0. The theta final is equal to some theta we can say. So I need to work done. So here see, when dipole rotates from initial orientation to, so initial orientation to final orientation, so the work done by the electric field, work done on dipole by electric field is, if you let consider W, that is equal to minus du, means minus of UF and UI. So here see, UF is what? UF is potential energy. Potential energy, that means work done by external agent to bring from infinity to the point, to point in field. The UI is also same. The work done by the external agent to bring infinity to point into the field. Means it is initially there is a dipole, means we are bringing the positive charge and negative charge from infinity and placing in the electric field. So there UI is there. So there is UI. So now this dipole from equilibrium position, now it is in equilibrium position. I am converting into some angle theta, turning into angle theta. So I need to do some work. And when the dipole is placed like this in the electric field, it has some work done, right? Field also done work done. I need to turn this dipole into this angle theta. I have to do the work done against field. Field I have taken as negative. Then my work done means external torque. The work done by the external torque. External torque is applied on the dipole to do some to turn some angle from theta I to theta f. Then my work done is negative of electric field work done. Is opposite to electric field. So that is equal to EF minus EF. That is, here I will explain this how it is coming P into cos theta F minus cos theta I. So now if you see, here the work done means tau into d theta, that is equal to dw. So now coming into w, dw integral 0 to w, which is equal to integral theta I to theta f. So that is tau means we know already Pe sin theta d theta. So that is equal to minus Pe into cos of theta f minus cos theta I. If theta I is equal to 0, as shown in the figure, if theta I is equal to 0, that means work done, which is equal to change in potential energy. So that is equal to Pe 1 minus cos theta, Pe into 1 minus cos theta. So this is the potential energy or work done. Yeah, this is change in potential energy, not potential energy. Change in potential energy or equal to work done, which is equal to Pa into 1 minus cos theta. So whereas potential energy means the potential energy is the work done. Potential energy is work done on dipole. Work done on dipole from 90 degrees. So this is, remember, from 90 degrees to any other degrees. That means initial state is 90 degrees. The initially dipole is in the electric field. This is the electric field. Dipole is with the 90 degrees. That is P bar. Now I am turning the dipole into some angle. So now dipole is turned some angle. So here work done is how much? So therefore that work done is called potential energy. So potential energy is equal to, potential energy means U is equal to Pe of cos theta minus initially cos 90. So that is equal to Pe cos theta. The potential energy U is equal to, not change in potential energy. Potential energy is equal to Pe cos theta. That means from 90 degrees to any other angle. How much work you have done against to the electric field, that is called potential energy. The difference in the potential energy means from one system to initial system to final system. The work done to change the orientation of a dipole from initial system to initially some angle theta I angle. Finally theta f angle. Therefore theta f minus theta I, cos theta of theta f minus theta I is work done, which is minus by the electric field, which is positive by the external torque. So this is the work done on dipole by electric field. Right. So now coming into some other examples. So now some problems, 4 or 5 problems I will explain in this video only. So now coming into here. So one dipole is there here. And one infinite long, one dipole is there as well as one infinite long line charge of linear charge density lambda coulomb by meter is also there. So linear charge density is given lambda and dipole momentum is P, means P is equal to Q into 2L. So dipole momentum or A I can take this distance A, and in the distance R meter. R is the distance from this charge to this one. Now this dipole is an equatorial line of this field, this rod field. The equatorial line of this, the linear charge means at this point field is equal to, I can know. Therefore, I need to force to find, right? A force is equal to here Q into E. You cannot find out, right? Because here dipole momentum. See, the field at this point 1 and field at this point 2 is different. Means 1 to 2, the field is varying. The field is varies from 1.1 to 0.2, means along the dipole momentum. On the dipole, the field is not constant, is varying. That's why the force formula is equal to P into dE by dr. dE by dr. So this explanation see here in the non-uniform electric field we study means. So there this electric field gradient will come. There I forgot to explain. The force is equal to, this is the answer. So now I know E is equal to here. E is the field due to the linear charge density, that equal to 2k lambda by r, I can write. So from the concept of the field due to a charged rod, so that is E is equal to k lambda sin alpha plus sin beta by d, where here alpha is equal to beta, then E is equal to 2k lambda by d, that is equal to lambda by 2 pi epsilon naught into d. So this already we know. So which is equal to, how much will come? Lambda by 2 pi epsilon naught into d. Now I am derivating this one, dE by dr. So here d is r. So that is equal to lambda by 2 pi epsilon naught is constant. Therefore d by dr of 1 by r. So which is equal to minus lambda by, so this is r power minus 2 means r square will come 2 pi epsilon naught r square. Here minus indicates attraction or direction of the force on dipole. Now the force is equal to dipole momentum into dE by dr. How much I got? The lambda by 2 pi epsilon naught into r square. That means force and P are opposite direction here. Okay, here minus came now. Therefore, P and force are in opposite direction. On this dipole momentum, force is acting negative x direction. It is attract. Negative here indicates, the negative indicates what here? Attraction of dipole. So I hope you understand this. 2-point dipoles P k cap, P by 2 k cap are located at 0, 0 means origin, 1, 0, 2 means x and z plane respectively. The resultant electric field due to the two dipoles at the point is on x-axis at the point 1. So let's consider. So here on x-axis electric field I have to find out. The two dipoles is along k cap. Therefore x and z axis I will consider. So from the given data, at origin there is a P along the z axis. So this is P bar. And at the point 1, 2. So here there is a one dipole along the direction P by 2. So asking to find out resultant electric field at this point. Here resultant electric field. So by seeing the diagram itself, we can say this point is equatorial line for P1 or P for P. So let this is point A. So A is equatorial point for P. Therefore, let this is E1. Field due to 1 is equal to K into P by. So this is 1 distance. So K by 1 cube minus J cap. Minus K cap. J not here K. Similarly, A is the point is axial. Is axial for P by 2 dipole. So let that is along the P. On axial line dipole is along the P. Therefore, field is equal to 2K into P by 2 by. This distance is 2. Therefore 8. to keep, right? So net field is equal to here. The net field is E1 minus E2 or E2 minus E1. E2 minus E1, that equal to minus 7p k cap into k, capital K, by 8. So this is answer. Now next model, a system of two electric dipoles. Each dipole momentum P are arranged as shown. So here diagram I am drawing. See. So one is, so this is y axis, this is x axis. So the dipoles are arranged at a comma 0 comma 0 is here one dipole like this, and minus a comma 0 comma 0 another dipole like this. So interaction energy, electrostatic interaction energy, that means du. So I know du is equal to minus f into dr. Du is equal to minus f into dr. And already I know f for axial dipoles, the force for axial dipoles, that means dipole on axial line, I know, which is equal to 6k p square. Here p1 p2 are same dipoles, two electric dipoles, each dipole momentum is p. So 6k p square by 8 a cube. The distance is equal to here 2a, right? Here to here the distance is 2a. So 8 a cube. So now this I am doing integration, then u is equal to minus 6k by 8 a cube, 6k p square by 8 integral a power minus 3 into dA, x cube into 2a, that equal to, so this is 2 will come. So now minus so force is equal to a power 4, not a cube, a power 4. So a power minus 4, that equal to minus 6k p square by 8 into, so this is a power 4 means a power minus 3 by minus 3. So 2 cancel 4, that is equal to k p square by 4 a cube. Already in the place of x, 2a I have substituted already, so this is the answer. So next step. So here see, the point electric dipole momentum P1 from the given, the P1 lying in xy plane, and it is held fixed at origin. So it is fixed at origin. So P1 bar. So along this is root 3 I cap. Along this y axis only one j cap. So now another point electric dipole of momentum P2 held at a point minus plus a comma 0 means a comma 0 comma 0. Here one dipole is held. Will have minimum potential energy. So the potential energy is minimum when dipole aligned along field. That means here I want to find out the field due to this dipole P1. So now root 3 I cap is the dipole of the axial dipole momentum, and 1 I j cap is perpendicular means equatorial dipole momentum for point A. Okay, the point A is axial point for root 3 I cap, dipole momentum of root 3 I cap. A is equatorial point for 1 j cap. I know then field on axial point, it is axial, opposite to equatorial point, it is equatorial point. The resultant field is in this direction. This is the resultant field, and momentum also along the same direction to get the minimum potential energy. Right. So now this is Px, P2x, and in the direction P2y. So now EA is electric field, which is equal to axial point for Ex is axial point for P2x. Means this is the point here. P2x is equatorial point. This is the EA field is due to E equatorial by P2. The EA electric field of P1 is equal to E equatorial of P2. That means K P2x is equal to 2K P1x by AQ. Similarly, so the EE electric field of dipole 1, so E is axial line for, means is P1 equal to E axial of or E equatorial of it. So that is K into P2y by AQ is equal to K into 1 by AQ. From this P2y is equal to I am getting 1j cap. From this I am getting here P1x equal to root 3. Therefore P2x that equal to root 2 root 3 is equal to P2x. Therefore now substitute these x values here. Root over 4 into 2 root 3, right? 2 root 3 means 4 into 3 minus 3, which is equal to 9. That is equal to this answer. Now there is a small electric dipole kept at the axial point, uniformly charged ring at r equal to distance r by root 2. So x equal to r by root 2, where r is radius. So at this point, dE by dx is equal to 0, maximum field. So in the ring you study, right? Therefore force is equal to, I know, P into dE by dx. That means the ring is given like this. So in the axial point x equal to r by root 2. So here one dipole is there along this. So at this point the force is equal to P into dE by dx along the x-axis. So that equal to P into 0, which is equal to 0. Force is 0 on the dipole due to this ring of charge, uniformly distributed charge on the ring. If other x value is given, you have to go with the dE by dx. X value something is given, right? Now next model. So coming into this point, a dipole of dipole momentum P is 2i cap minus 3j cap plus 4k cap is placed at a point. Means initially the dipole is placed in the space at point 1, that is R1. Here P1 is there. I don't know the orientation, how it will be oriented. Because 3-dimensional space, na? X, Y, Z. At point 2, minus 3 and 4. By taking the cube, we can represent that dipole, but no need here. So at the point P in the distance R1 of distance from the origin, at the point P1 there is a dipole. So P bar is equal to 2i cap minus 3j cap plus 4 cap. Now electric potential at the point. So that is 4 comma minus 1 somewhere. 4 comma minus 1 means here. So this is the point 4 comma minus 1. So at this point from this dipole, I want to find out potential. So you know potential due to dipole at any point can be written as Kp cos theta by r square. It is already in explanation I have given, right? Now cos theta I don't know. This I can change in vector form. I know P cos theta can be written as P bar dot r bar by r, that equal to P cos theta according to dot product of P and r. Therefore K is equal to P bar dot r bar by r cube. So that is equal to 9 into 10 to the power of 9 into P bar dot r bar. Here r bar also I need to find out. So this is r bar. Means r bar is equal to 4 minus 2, 2i cap, minus 1 plus 3, 2j cap, 0 minus 4, minus 4k cap. Now if we substitute this, 2 2 ja 4 plus 6 minus 16 by r cube. So r is equal to, the magnitude of r bar is equal to 4 plus 16. That is 24, the root 24, right? I can write root 24. 24 only, na? 4 plus 4 plus 16, right? Your point is not 4, this is 1. Sorry, 4 minus 2 minus 1 minus 3, 0 minus 1 minus 1 cap. So 1 this is. So 9, that equal to root over 9, that equal to 3, 27. And here also this is 1, right? Sorry, 4. 4 4 get cancelled, 6. That equal to 3 3s, 3 9s or 9 1s, 9 3s. So 2 into 10 power 9 is the answer, right? That is potential poles. So now dipole consisting of plus 1 microcoulomb and mass 1 kg, and another which is charge minus 1 and mass 2 kg. Here mass are not same. Mass are not same means need to find out the center of mass of the dipole, because about what it is the rotating. So let's consider this is the dipole momentum P, making some angle theta. Now this is 2 kg, 1 kg. The charge is equal to 1 microcoulomb minus this is 1 microcoulomb. So now center of mass near to the 2 kg, and total distance is given 3. Therefore center of mass is equal to the 2 into 0 plus 1 into 3 by 3. So 1 is coming. Center of mass is 1 from 2. So therefore moment of inertia equal to 2 into 1 square plus 1 into 2 square, which is equal to 6. And P momentum, dipole momentum P equal to 1 microcoulomb, 1 into 10 power minus 6 into distance 3, that equal to 3 into 10 power minus 6 coulomb meter. Now E electric field is given 20 K, means 20 into 10 power cube all by meter. So now is asking to find out the equilibrium position angular frequency. From the angular frequency in the uniform electric field, field value is given. It is separated. Small oscillation is about its equilibrium position. So torque is equal to I alpha. The tau is equal to I alpha. I into d square theta by dt square. So tau is equal to PE into theta is equal to I alpha. Therefore omega square is equal to PE by I. We substitute, you will get answer, right? So P already 3 into 10 to the power of minus 6 into E is equal to 20 into 10 power 20 cube. So PE by I value is equal to 6. So now 10 power 4, this is equal to omega square is equal to, coming answer 1, means 1 into 10 power minus 2. And replace omega equal to 10 power minus 1, the radian second. Omega I know, then I can find out time period also. Time period equal to 2 pi by 1. This is another model. A tiny electric dipole momentum P, means from the diagram it is along the J cap. So P is along J cap, P not J cap. So place it at, means this is not origin. So place it here at L comma 0. That is not 1 comma 0, L comma 0. There exists electric field. So in this plane electric field exists 2a x square I cap, and this is given. So here dipole is along y axis. This is dipole momentum P naught. Now asking to find force on dipole. Force is equal to given dipole momentum into dE by dx. So that equal to dipole momentum here. The dipole momentum, the dipole length is varying along the y. Therefore dE by dy, not dx. dE by dy. So that is equal to P naught into dE by dy means 4 by plus 2c j cap. So now along the y cap, so see here y is equal to 0 value is given. Along the y direction, the y is equal to 0. Means x is the P is perpendicular to x axis. Then y values are 0. So this x value is 1, y value is 0. Therefore, this y value 0 is substitute means 2c P naught j cap is the dipole momentum. Means force on this dipole which is placed at L comma 0. On this same model, another one see in this row only. Electric dipole momentum is given here x axis. So dipole momentum is given along x axis. Is kept, the dipole is placed at along x axis in the xy plane at x comma y point. This is y, this is x. So now dipole is placed like this. Okay. So now field also given. E is equal to given. E bar is equal to 4x square 4xy square. In the question given clearly 4x square y along there. So now P is varying along, means the length of the dipole is varying along the x-axis. Therefore, the force on the dipole is equal to this P into dE by dx. The force on dipole is, means by the electric field is acting in xy plane, right? The force along x-axis and force along y-axis also. So force varies along dy by dx the same way. So P into dE by dy also changes. So here dE by dx there is no change, right? dE by dx in this problem. But here dE by dx as well as dE by dy also varies. Force. So now dE by dx force is equal to P into P naught into I cap. So do this dE by dx and one time dE by dy. So I cap along the I cap dE by dx along the J cap dE by dy will do. Otherwise total dE by dr dx and dy. Yeah. So which is 4x means dE by dx means 4y square along I cap plus dE by dy along the J cap equatorial point, right? That equal to 4 into 2x into y dE by dx. This is right. This is also x only. So now only along the x-axis I am derivating. So P naught into here 4y I can take comma. So remaining is this is I cap, this is J cap. So remaining is y I cap plus 4y I have taken 2x J cap. So if you want to magnitude of force, P naught into 4y root over y square plus 4x square. This is answer. So now conceptual questions here on potential energy topic. So you see this is the E direction is given in the diagram. So 0 to some angle theta, 0 to some angle theta. So here potential energies are 1 and 2, potential energies are same. Means 0 to theta. So potential energy formula actually PE is equal to, potential energy is equal to electric dipole into electric field PE into cos minus PE into cos theta by the external agent. That is equal to minus PE into cos of theta f minus cos theta I. So already this I have given in the concept. If people are very clear. By the external agent, not field. Field always trying to keep the dipole in equilibrium only. So it is making some angle means external work is done on the dipole to be in that position. This point is very important. So therefore work done by external force, work done by on the dipole, external work torque on the dipole is equal to integral of PE sin theta d theta. In the work done we studied right, that equal to minus PE cos theta final minus cos theta initial. So here cos 0 initial means 0. So in the first case 1, in case 1 0 to theta, 0 degrees to theta degrees. So that equal to PE is equal to minus PE into cos theta f means cos theta minus 1. So that is equal to PE into 1 minus cos theta. Work done by agent. So which is equal to negative of work done by the field opposite. Similarly, if we see in the first and second same only, magnitudes are same, but direction is opposite. Coming into 4-3, your work done is from 180 to theta. Its work done is from 180 to theta. Therefore, PE is equal to potential energy is equal to work done is nothing but change in potential energy EF minus EA. Once it is by external torque means minus of PE minus PE into cos theta F minus cos theta theta I. Work done by the electric field means minus of minus 1. Minus of work done by external agent. So that I can. PE is equal to here minus PE into cos theta F means cos theta minus cos 180 plus 1. Minus 1 actually minus of minus plus 1. That equal to minus PE into 1 plus cos theta. So 2 and 3 also same work done, right? 180 to some angle. Therefore, the work done by the second dipole and third dipole is same. And it is more 1 plus cos theta is 1 minus theta. 3 and 4 is means 1 and 2. The work done by 1 and 2 is this much. The work done by 2 and 2 is this answer. Therefore, is asking increasing order. 2 and 3 same, right? 2 comma 3 is greater than 1 comma 2, sorry 3 comma 4, 4 comma 3 is more work done than in 1 and 2. Angles, if you see here, theta 0 to theta, so here this is 0 to some more angle, and this is more than that, this is, so 2 is greater than initially, and 3 is greater than 4 is greater than 1. Therefore angles, you can measure them in the increasing order. Plus energies, 2 3 is same, 2 2 3 only, na 4 3, 4 3 is same, 1 2 is same, 1 2 is less, 4 3 is more. And coming into angle, second angle is more, then third angle means positive x axis to this is like that. So these are the two answers given here. Any other answer can ask once verify. Okay, thank you all, thank you.